just a child, like everyone else, but I used to pull apart all my mother's anything she would buy, like a television and stuff. I would just rip that stuff apart and figure out how it works, and that's how I started my journey. And then I a few years ago I hacked my car for self-driving, and then my son was learning coding at school, and I'm like, wow, we've got to really upskill kids and give them better opportunities for what they're going to be going into, because technology is racing ahead and it's leaving us all behind. And we've really got to give kids the best tools and opportunities for their future lives, because it's going to be very different from the day we're living in currently.
So what we're going to do, we're going to break up in two groups. You're all going to get a chance to be with me and with Bruce. So we'll do about 20-25 minutes and then swap over. And then we'll come back at the end, and one of the lucky teachers is going to win an Amazon $50 gift card as well. You have to answer maybe one or two questions. I also want to say thank you very much to Jody, that has jumped in with us. She is actually going to stay on the link with Bruce on KaiBot. So KaiBot is our hybrid robot, our screen-free coding robot, and then Kai's clan is the yellow robots that does the AR and the VR and all that. So we're going to give you a little bit of an overview on both those products, and then we can always follow up later with more demos if you need some. So Ashley, can you sort of just break up the team, just in two different groups, and then we'll just jump back in. So just Jody needs to go with Bruce, and then the rest can just share them in the two rooms. Thank you.
So I'm going to go ahead and do it automatically. So Jody, if you end up in the wrong group, there is on the right-hand bottom of your screen, there's boxes. It looks like a Rubik's Cube. It says Spaces View. If you go there, you can click on that, and then you can just switch to the right group, just in case it moves you to the wrong one. So I'll go ahead and move over everyone. There we go.
Awesome. Oh, Jody's with me. Jody just jumped back. So yeah, thank you very much. And firstly, let me ask, are you primary or elementary or secondary schools? Elementary?
Bruce, it looks like you're on mute.
Can I maybe have a hands up who's elementary or thanks, nobody elementary? Okay, secondary school then. Secondary. Don't know about Heather, Bob, and Sherilyn. I can't see. I'm catching you at places where you. Are you secondary as well?
Sherilyn is in elementary. I'm sorry, I don't have video.
Okay, Sherilyn, elementary. Bob?
Secondary.
Secondary, and Heather?
Hi, I'm just here with Idea.
Oh, okay. Oh, sorry, that's Heather. Thank you. Okay, so what I'll do, Sherilyn, I will go through it quite quick with sort of just the basic of coding, because the basic coding cards is probably using for elementary, the screen-free coding cards. However, even with KaiBot, it goes all the way up to secondary school as well. But Bruce is going to look at really just at entry level. We will come in probably that age 7 years old and upwards. So I'm going to share my screen. Let's see if we can do that. Share screen. It's always a interesting thing, and see if I can actually really. Can you see my PowerPoint?
Yes, I can.
Okay, I'm going to go through this really quickly. It's just an overview, and then we'll jump onto the product. So it's a toolbox, and you can see it does the Python and Blockly. We use Tinkercad and Minecraft for robot avatars, sensors, AI blocks, AR, and VR. So it is for elementary and secondary school robot avatars. So this is where we always say, we've got this robot, And actually, wherever the robot moves, you can go and upload a robot avatar. So you can have Steve, or you can have Harry Potter or a cat, that when you now code your robot to move, those characters will be moving. It's multiplayer, so it's all about collaboration. So we really want students to work together to solve the problems. Coding, like I said, is a switch between Blockly and Python. We do AR, we do VR, like with the Google Cardboard. You can just put a phone in. We cover sensors. So obviously for the secondary school teachers here, this is really, really important and a lot of fun. We've got 35 sensors, including that you can use your microbits as well, and you can export all that sensor data to an Excel spreadsheet or a Google sheet. Now, I really believe that from a young age, we need to teach students how to read an Excel sheet. And that may just be how to go from A to B, but we can get much more advanced with the sensors for Kai's Clan. So we've got 65 different lessons, cross-curricular. So it's not just computer science or not just sensors. You may want to use it in the biology class if you want to do plant watering or want to study bees. We've got those lessons. Social studies, if you want to look at the Mars mat. So we've got a Mars mat, a warehouse mat, a rescue run mat, which is a bit like castles and in fields, so it's a bit like Harry Potter, Minecraft environment. We've got a smart city, and then we've also got a create mat, which is a clear mat. Products, you can get this from Ideacon. Classroom pack is probably what most schools now order, which is 12 robots with 2 mats, and then you can order extra mats. Right, let's stop that. Oh, where's my mouse? Let's go over to... Okay, so you can see on my picture, this is a top view and a side view. So if I move these little robots, now you may think for secondary school, those look a little bit kiddie, but that is why we can then go and upload robot avatars. So I'm going to share my screen. Oh, sorry, let me just go back. So this is on the Mars mat. It's a 80 centimeters, what's that in inches? It's about a 3 foot by 3 foot mat. They are very durable. You can put them in the washing machine if they get dirty and get stepped on and stuff. So it's not a problem. And we use QR codes so we can see exactly where the robot is on the mat. So we can start teaching X and Y coordinates and a lot of maths lessons as well. So I'm just going to share over to this screen. Okay, can you see this dashboard screen? Hopefully, yep. Okay, so on the right hand side, this is my mat for Mars that's on the table, and you'll see I've got 4 robots sitting on the mat. Now on the left hand side is my coding blocks. So if I literally just want to go mat movement, go X to Y, or if you're just an elementary student and you're just going to go move forward 10 centimeters, we can do that. So you choose your robot, and I'm going to choose a robot 9, and I'm going to move to 2020. There's a lot of robots on here. So let's just move them a little bit to the side so we don't crash into too many. And I just click my run here at the bottom left. You will see that robot 9 is going to move to 2020. So there he goes. So that's a 2D representation. Obviously, it's a physical mat that's sitting here. And you can do all the different coding blocks. So I can go move forward. I'm going to maybe go, we're just going to add a couple of blocks in here just for me to show you. We'll go move forward, say 15 centimeters. And maybe we want to play a sound, because you guys can do that. So there's sounds, there's all the bits. and we're going to look and maybe play Simpsons. So this is what your Blockly looks like, and we can run that. As a teacher, you have got control of all the robots. A student, when they log in, they only can code their own robot, but they can interact with any other QR code, which is a whole bunch that you can print out and put on Lego or create 3D printed models that you can interact with. So before I look at this code, if you want to then, just for the secondary school teachers as well, you can just click on this Python and it loads your Python. So I'm just going to cover off the two quickly, the languages. So you saw the Blockly. Here's our Python, and it's a really good translation. So say I want to go backwards. So I want to move. So I can just go move. It shows you all the blocks. I want to go backwards. I want to go robot 12. And I tab. I want to go backwards, say 30 centimeters, tab, enter. Now in the back, if I actually close my Python again, you would see that it automatically adds my move backward block in Blockly as well. So those students that start crossing over between Blockly and Python, this is a really good tool for them to then jump in. So under your coding, you've got Sandbox, which is everything to do with the 3D, which I'll cover in a moment. But the normal blocks as free movement. You've got gripper bars. So obviously with your robots, you can open and close and go and pick things up, which is really special. You have got special blocks, which is your AI blocks. So I'm just going to go back here, movement AI. So for example, I can go to the ice. So if I just want to move this block, I'm just going to take this out and go robot 12. I'm going to put you over there, close, and I'm going to say navigate to the ice, robot 12, and we use some AI here that's going to then make it go to the ice. I'm just going to move that robot back. So he's going to then move, and he's going to sort of follow the little path. You'll see those dark edges on the mat, which is where you'll see when we go to the virtual world. That is actually your craters. Now, one thing to note is that the robots won't drive off the mat. They are hard-coded to stay on the mat. So even if I put him on the mat, we'll try and move him off the mat, you'll see he reverses back. So the coding block, we've got bits. This is where all your sensors are that you can add on, and it's got a couple of sensors on board as well, and then the microbit as well. You've got your normal logic blocks, loops, function, and maths. So you've got newbie, which is very easy blocks. There's only a couple of them in there, for example. And if I go to expert blocks, still motion and free movement, there's just a whole. You can then turn left, turn right, and we also introduce like true and false. So that's all on the coding block side. Coming to the right-hand side, your classroom management is really, really easy. So basically here you just enter your student names. So Terry, if I want to add you, I go Terry, and I say you are robot, let's see, 12, it's been allocated, robot 12. And I can just save that. And now you can go and log in. So this is all on a web browser. So Google Chrome, Edge, Safari, you can use it on an iPad for the elementary school and just code on the iPad. And this is where you would add your students. We don't take any student names. If you want to just call them Robot 1 or Robot 2, or you want to give them planet names, it doesn't matter to us. We only get the teacher when you register your account. Now, if a student has a problem and they need some help, then you can go and click on this assistance, and it will actually show. You're going to go and remotely look at what Bruce has been coding so far, and then you can give him some tips, or you can help him. So he's done open gripper, and then you can say, well, Bruce, you actually needed a move block in between. Otherwise, it's just going to go open, close, and okay, that's what you need to do, and you save, and then he can actually carry on with his coding.
Okay. So I don't know how many of you have done.
Okay, sorry, I just heard some noise. Projects.
If you haven't, no worries.
So if I click on projects here, this is where all our lesson plans are. So if you go to the Kai's projects, we've divided them into the different mats. So say I come to the Mars mat, I can actually just click on any of these pink blocks. Because we talk about collaboration, we really want them to do different things, the students. So say, for instance, we're looking at, this is probably about a 10, 11-year-old student, and they're going to be a sorting rover. You click on these little pink blocks. Now, it loads some sample code. We use, obviously, introduce logic already in here for those students, and you can also create a classroom variable. Now, they can't just hit run with this, but it shows them an example. Now, if you click on the question mark over here, this is where it loads the lesson plan for the teacher. And it will say how long this lesson will be, what are you going to need, and it show what that code is going to look like in the end. And the student, when they log in, they get a little bit of an overview of what you're trying to do. There's a little YouTube video, tells them what the sorting rover needs to go and do. Their classmate is going to be the storage robot, and how they then set up and build up that code. So it's all there of what they need to do. So that's projects. You also have community, so any teacher can go and upload some lessons here, and we've got lots of teachers that you can even just send us the lesson, and then you can share it with the community, which is really, really cool as well. Okay, so that's projects. I'm going to come back and ask questions just now. Just quickly want to cover some of the things. So on our sensors, we wanted to make sensors really, really simple, that even elementary students, elementary school students can start looking at sensors. So for example, here you will see I've got my robot. At the back there's a port with two little ports here. Just want to see, can you see? Oh, you can't see me. Let me just stop sharing my screen.
Introducing Python.
Okay.
This is a great way to do it. So, like you were saying,
all right.
at least
So I think down there. So I've got two ports here. So on the box, big box. Where's my box?
You know, possibly in a future lesson, and actually
big box of sensors. It tells you if it's a green sensor or a yellow sensor.
physically touching the cards.
So in here, I've got a light sensor that I've basically connected on here on the robot. Now, if I go back and share my screen, share screen, this screen, share. Go back here. I go to my robot. I go robot 12. Oops. Sorry, open it up. Robot 12. It was a green sensor. Choose my sensor down here and just type in here light, and the light sensor is there, and then you select it and save it. So that's already been done on my sensor. So all your sensors, that's how easy it is then to add a sensor. If I now come back to my little map and I click on robot 12, down here you'll be able to see the light sensor. So at the moment it's 83%, and if I actually take my finger and put it over and cover it, you'll see the light sensor is coming down. So for example, I've got a lesson on Mars, and we say when the sun goes down, all the Mars rovers need to go back to home base. So you can say if sun goes down, move rovers back. or you can use ultrasonic distance sensors, or you can say if the humidity, the temperature, you know, all those kind of sensors you can then use. We've got a water pump, so in biology actually, you can have your moisture sensor, and we've seen primary school, elementary school kids do this lesson, really, really simple. Robot 1 has got the moisture sensor, you put it in a plant, and then you say, if the plant is less than 20%, so it's pretty dry, Robot 2, you put on your little water pump, and you go and water the plant. So we can do a little bit of smart gardening as well, to then do timing, and they can go and water the plant. So that is all around sensors. There's loads of little YouTube videos on the Kai's Education channel that you can go and see. Now, the most fun for students is usually this virtual, the 3D view. So basically, what we've got is we've got a, you can either go to Tinkercad or Minecraft, go and create some files, and then you can upload them or send it to Kai's Clan. It all comes in automatically into your dashboard. So I've now got, say, R2D2 or a little couple of characters here. And what I'm going to do is I'm going to go and open my virtual viewer, which is my 3D viewer.
Download this project into Conundrum, and if I just
load this, and when this is loaded, you will see I am just going to go and just move my code out the back here.
And these tiles that you see
while that's loading, and I'm just going to go move forward 20 centimeters.
But they can be, or it can just be virtual only.
Mute this.
And in this game, I've got
robot.
a cube drop. So
do this robot. It's robot 12.
I've got different things, and you can see it's pink.
And this is now my environment in 3D. But I may say, okay, I actually don't want this robot. I want R2D2 to be my robot. So robot 12, I'm doing this all below here. I can actually just minimize it. Robot 12, let's move this out. Oops. Move that out. And I'm going to run it, and you'll see robot 12 is going to turn into R2D2. Now, you can size him, you can rotate him, you can scale him up, you can animate, put fire, speech bubbles, emojis. So there's a whole range of things that you can do in the virtual world as well. So if I now just want to go move forward 20 centimeters, robot 12, you will see that he is now going to move forward. And there he goes. Now what I'm going to do, I'm just going to go to the home page, and I'm going to stop sharing my screen, and I'm going to run across and put my camera in front, my iPad, to show you the AR. This is like super fast showing you all these things. So on my iPad, I can download my Kai's viewer, and you'll see the AR and the, well, I can't show you the viewer, but I'm going to show you the AR. So just watch this map. I'm going to come across.
And everybody plays. That'd be a single player version of it, right? We'd all play the game, and then the real power comes in. What Bruce is probably going to show you next is how to design your own maze. So there's problem solving there. You come up with your own challenges that you add. Ways to, for classmates when they play your game, to score points, ways to kind of make it more challenging for them to get through your version of the maze. You can color code it like you see in this game, all kinds of fun, creative ways.
Right, so that was super quick to show you some AR, and I think they're going to break us up just now, and you're going to see sort of what KaiBot is doing as well. So that's a really, really fast. We can do one-on-one sessions with you. We just wanted to show you a little bit what is Kai's Clan, which is a toolbox, a STEM toolbox, and you can then really carry on with that from literally from that probably grade 7 or 8, and use that for your students all the way up to the age of 15. I call it ages just because in different countries it's different grades that we deal with. But you know, elementary is move forward, just introduce them to some Blockly and a little bit of 3D. The older you get, you start introducing sensors, use those, the data. You know, I can now say with my humidity sensor, the warmer it gets, let R2D2 grow. Or maybe it's not R2D2, maybe I create a spaceship in Tinkercad and then I can make that spaceship fly. So, any questions?
There's a whole game builder in here, so we can create our own games. And
Terry, have you got a question? I'll go through. Can you unmute you, or you can't?
Yeah. How are we doing for time?
I can unmute myself, I guess. No, I mean, I'm just catching up here. So, I mean, I got the gist of it that you are building your code in either Python or flipping back and forth to Blockly, and then you're able to animate the robots, but then you're able to view them in 3D with the AR.
That's right. So
really, I'm just kind of grasping what the whole possibilities are here. So, and then, but you interface with Tinkercad too. You were saying you could actually build your projects there and then animate those.
Yeah. So you can go into Tinkercad, create it, and on the right-hand side of Tinkercad it says Send To. If you look at that Send To button, there's a couple of third-party partners, and you'll see Kai's Clan is in there. You send it to Kai's Clan, and then literally it comes in, it goes sort of through a washing machine. We optimize that file, and then they can just go and load that to their robot. Right, Bob, any questions from you? No, you're all good. Julie?
Thanks, Lana. That's really good.
All good. Sherilyn?
No, just like Terry, I'm just trying to absorb everything. There's a lot of possibilities.
Yeah, and you know, it's very overwhelming. You're gonna probably walk away at the end of this and go like, oh my God, this is so complex. But we just want to give you a taster. To sort of say, this robot has been out there probably for about 3 years now. We just won in January at FETC, we won the DA Top EdTech product for 2022 next to Lego Spike. So it's really showing the possibilities. This is a robot that's not a line following robot. It's sort of, we always think about it as it's that next step up from a Sphero ball. You know, you can, I mean, Sphero is great, but we sort of find that the kids are engaged for maybe a couple of weeks, and then what? We've actually got schools that run Kai's Clan all year round, and this, you know, touch, if it's coding or if it's sensors or if it's AR or if it's creating their own projects, they can do all of that because it's about collaboration. Right, now I think they need to switch us over. Heather, I don't know if you can, or Ashley, start moving over to the other room or swap over. Oh, Bruce is back.
Establish rules and how to talk to each other in ways, you know, you can bring up what toxic gaming looks like and how we communicate to each other in a positive way, how we support each other. And so all this can, you know, you could do a whole unit on creating fun and friendly games with a focus on digital citizenship. Yes, and those are linked to your cards as well. Yes, SEL as well. Yes, for sure.
See, Bruce is still busy.
It looks like Ronell is...
Sorry, Ashley, we can't hear you.
Okay. So what I'm going to actually have you guys do is you guys be the one to switch rooms, if that works okay, instead of moving everybody else over. So what you'll need to do is on the bottom right-hand corner, there's the Rubik's Cube. It says Faces View. Do you see that?
Yes, yeah.
And you should be able, once that comes up, you should be able to click on the other room and switch over. Or double-click on that to switch over.
There we go.
Bruce, do you want
Hey guys,
with you?
how you all doing?
Yeah, Jody, you should probably move.
Was that previous session board? You can unmute your microphones.
Okay. So.
Oh, thanks, Jody. Was good. Awesome. Okay, so our session was all about really getting started in coding. Like if a child is coming to you and never coded before. So hands up if you've done some form of coding before. So okay, right. So let me just switch cameras around, and then we'll have a start. So this is KaiBot, and KaiBot's a cute little robot, and it can read these coding cards that we've got laid out. So what I've got here is I've got a square of these magnetic tiles. So you can see these tiles here, and they can just snap together. So you can like build loads, really large environments for kids to solve mazes. But before we get into solving a maze, we have these this messy area down here with some coding cards. Right, so what we can do with these coding cards is if a child has never learned to code before, it's a great place to start. So we could say we always start a program with a start record card, and then we move on to a forward card. Now, with any of these cards, they've all got these connectors, just like a circuit board. So they're really cool. So you can add, and you can see there's a green asterisk. Now with a green asterisk, we can add a number card. So we can say move forward 4 times, and then say turn left. So I'm sure you guys would really, you understand what I'm getting to here. And then I would say end the program. Like all good programmers, open and close their brackets. Now, the cool thing with KaiBot is it's like going shopping. It's like got a barcode scanner type thing in it, and you can just tap on the card, and then it says what it's scanning. Forward 4, turn left, and end the program. Now I can run that program by just tapping the run card. It's got a little countdown, and then the robot is going to move forward 4 sections. I'll just grab him there, and then he'll turn left. There we go. So problem solved. Okay. Now, how do we any ideas on what code we would need to code this square? What functions would you use to code this? Any ideas? Yeah? Julie?
I just want to ask, what do the numbers mean on the square?
Okay, so on these tiles, these are just unique tile IDs, and we can use those later on. Each tile is, we can use this code without the tiles, but the tile IDs are all unique, so that means we can refer to the tiles in the code. For instance, I've got a variable card called read tile ID. Then I could say, okay, if I'm on tile 18, then turn left or turn right. Does that?
Yes, thanks.
Okay, so what we need to do now is we need to move around the square, but instead of just saying forward, left, because we would say start the robot over here, move forward, and then left, we could then start using a loop card. And we can get quite advanced with these cards. So we're going to say loop. Any ideas how many times I need to loop around to move around?
Free movement is very, very simple. You would see
Julie, any ideas how many times we would need to?
3.
3, okay.
4.
4, yeah, that's it. So 4. And then any ideas what the next card would be? Putting you on the spot there, Julie.
Oh, that's okay. End program or stop.
So we're going to say loop 4 times, and then we need to move forward. Now, every time we say move forward, it moves forward 1 tile space. Okay.
Oh, okay. I'm sorry. I thought you already had the code before the loop. So the loop.
Oh, no.
The loop comes first and then the program?
Yes. Here we go. You get a better view of what I'm doing.
Okay.
So we're going to say start program. We're going to say open the loop. How many times do we need a loop? 4 times. Technically, I should have this, I should move the card, but just with the camera. So forward, we're going to move forward
2 times.
2 times. And
then
then we're going to turn left. Then we're going to end that loop and end the program. Is that clear as mud?
Yes.
So now what we can do is we scan the cards.
And I'm going to click on my robot. Let me just get to robot 12. There's robot 12, which is R2D2, and I'll show you how we.
So this is a prototype. This is coming out in a couple of months.
If I now run my code,
put the robot on the tiles now.
It's going to move forward.
We should see that work. So forward, and on the screen it shows you forward, left. Now what's really happening on the tiles is if the robot slips, it will correct its position, and this little skirt will keep catching.
So this was really basic.
Okay, that didn't work because my little cardboard elephant skirt that I've got on this robot has flipped down. So I'll just take it off.
Let's look at some expert blocks. So they've done all the
Just
basic
testing these cardboard things.
Go motion, still the same mat movement.
So I can still run the program again, and we can replay it.
The same block that I used, robot 12.
Now while that's running, we can also do if statements. So we've got if else then, ender.
I can go to mat movement. And now
We've got functions, so we can nest functions.
So I can go and say, okay, position of mat.
We've got operators, so we can say if something's greater or smaller than something else. And like you were asking about the tile numbers, we can read the tile numbers, and we can also do maths, so we can do addition and subtraction using variables and setting variables to values. We can do color mixing, so we can make our own colors, and then we can also do social emotional learning. Now on the back of all of these cards is handy information.
Navigate to the ice. So we're going to delete that block.
So
Navigate to the ice.
what we can also do, if the child makes an error, let's say they forget to add a number after the loop card, we can record. So I'll just record a loop, and I'll say forward. Now it gives the robot gives the user an error, and it says missing number card. So that means that I need to have a number card after my loop in order for that to work. Jody, would you mind giving an overview of how you've been testing Kai's plan and Conundrum?
Sure. I was lucky enough to borrow a prototype when I met Bruce at the IDEA conference in February. And the way I introduced it to my students was basically kind of like the way Bruce has laid out these tiles. And we had it on a media cart, and it's been a great opportunity for students in small groups to talk together and figure out the cards. the students that I worked with had all worked with Blockly coding and Scratch, but this was such a great opportunity for them without being told to read the back of the cards like Bruce mentioned. There's instructions on the back, and to experiment, to brainstorm, to collaborate, and then, you know, to fail together, and then to ask each other smart questions, and to get just a little bit you know, independent from me, because on purpose I didn't explain the cards to them. They were so excited to actually use the scanner, you know, just like you do at Target, and to actually code it themselves and to figure out how it works, and then to build on and make their code more complex without me. So it's just a great opportunity for students to get talking. One of the things that I've been tasked with my technology team is to really next year help support nonfiction text, because I teach all students K-8. We really want to give students more opportunity to be reading nonfiction text, and this is a great opportunity for students kind of on their own to be reading the back of the cards, figuring out the directions, making a plan, and working together on problem solving. So I can't even tell you, I wish I could show you the videos of how much fun students have when they work out this code together. And this is just the beginning.
Yeah, that's right. So this is just the start. So what I'm doing now is I'm going to share my screen with you. This is our new platform. So this is called Kainundrum. Now you can load this, you can play with it in your classroom, you can test it out. It's a multiplayer kind of code, game, and maze solving thing. And what I'm doing now is I'm pairing my robot to Conundrum, if we see there, and I'm loading my player profile. So each student gets their own unique player profile, and just got to wait for that to load. We'll try and speed it up with everything running, cameras and everything running. It'll take some time.
Can I talk a little bit more about this platform while we're waiting? So the first thing I did with my students was introduce them to the, you know, learning to code the KaiBot around the mazes together, and that got them working in small groups. And then what Bruce is going to show you now is their web-based platform, which doesn't require, you don't have to install anything, right? It works really well in our Chrome browsers, on our Chromebooks, and also on computers. But the great thing about this website is that students can have an opportunity to first play a game and go through in a virtual space, them either with their keyboard and move the KaiBot robot around, and then the next thing they do is figure out how to build their own mazes. And the real, you know, one of the powerful things is that they can very quickly experiment with, like what Bruce is showing you now, using Blockly coding to actually control the movement of the virtual robot on the screen. So the learning is just so much flippin' fun. They just have a blast with it.
So inside Conundrum, we've got Blockly code and Python code, and what the students can do is they can create their own profile. So I'm just going to let's just try and get this paired again. I think that's working now. Oh, no, it's loading again. Just get another robot that I've used before. Sorry about this. It is a prototype, so.
And another thing that's really cool about this is when you introduce the Kainundrum virtual space, students have so many choices. What Bruce is showing you right now is they create their own, you know, virtual avatars. Basically, they're customizing their virtual robots, which just gives them the power of choice, so that they're hooked from the beginning. So they're having fun right now choosing the background colors, and then so that makes the next step, which is, oh, and by the way, you're not just going to use the keyboard to control your robot, you're going to code it on the left, and it encourages them because they'll win more points as they move through the maze if they're coding. So they get hooked from the beginning because it's so much fun, and they forget that they're learning. And then once it gets a little bit challenging, and you know, not all the students are going to be ready for the same level of coding. They're having so much fun that the challenge is, the challenge isn't, it doesn't worry them because they're having fun. So there's a whole SEL component to this that's really powerful.
I'm having a lot of fun with bugs at the moment. So excuse us. We are about 2 months away from final release, so I'm really having a hard time here. But anyway, let's do this. All right, so I'll just refresh the browser. So it's all in the Chrome browser, both the 3D interface and the coding. And like Jody's saying, kids can use the joystick, control the robot. Okay, we're in now. So your kids come into a waiting room, and you can use Google Classroom. So you can have all your students come in. We don't collect any names or anything. So each student has their own IDs. And you can have up to 30 players join. On the free account, you can have up to 6 players. And then what we have is we can click Start. Now, when we click Start on a game, it is a multiplayer game or a single player game. So we can have, like I said, up to 30 different robots in here. And the cool thing with Conundrum is the virtual matches the physical. So if you have the physical tiles and the physical robot, you can have both physical and virtual play happening. So if you have 5 physical robots and 5 virtual players, if a physical player crashes into a virtual, they won't be able to move. So I'm just using my joystick here at the moment, and I can move around. And while I'm moving around, I can turn on different things. So I can turn on a sentry mode, which is like a radar. And with this radar, I can detect objects. Let me just mute this audio. So for instance, here I can say sensing. So like, let's say movement, turn to an angle. So we all know what turn by an angle is. But I'm going to use some modern technology, which is using a car's LiDAR radar to sense the angle of this box. So you can see there's a box, there's a red cube in front of me, and it's been picked up by the radar. And if I just run this code, it's going to change the angle of the robot to the box. So as you can see, it's turned. So if I manually turn the robot and I run the program, it turns directly to that box. Now I can say move to, because I know the angle of that box, I can actually sense the distance to that box by using the radar. So I'm saying turn to the angle, I run that code again, and then move to the box. There you go. So 2 lines of code, and I've programmed that robot to now go and collect that box. Now I can say turn on electromagnet, energize, and then let's say move.
I don't think so. I have to order this, so I'm hoping they'll order it for us, so we can start at the beginning of the school year. So I'll probably have lots of questions.
So now you'll see the electromagnet is engaged, and now the robot will move backwards. So with Conundrum, this is just one game, but under the projects, we have loads of games. So there's weekly challenges, and there's lessons, and there's Google Doc lessons in here as well, and you can sort it by age and stuff like that. But I think Jody, you used your kids were all designing games, weren't they?
Right. We did a unit on designing safe and friendly games, and so students had the option to either use Conundrum or Scratch. And the vast majority of my students actually designed their own Conundrum games. And one of the things that I love about this is the creative component, like what you're showing them right now. Every game is different, right? Every challenge is different. So there are some students who really are into the creative aspect of designing a challenge, and there are some who are more advanced and they want to make it more intricate and more of the problem solving. So it really does and then there are some students who are happy just to figure out the basic Blockly code, and then you'll have some students like in a group of 10 who have pick up on Python really fast. So everybody can be playing this, and it really meets everybody where they're at, and there's the threshold, the threshold is really high, so students can be challenged and taken to the next level. They can be creative. It can really meet their needs and also challenge them to take them to the next step when they're ready.
So here I've created a laser and some mirrors, and I can actually set different types of events. So I can say on this laser, if somebody triggers the laser, then I can say open the gate, open gate 4. So every object is identified in the game editor, which is what we're in now. And we've got other things where we can color zones. So we can have escape rooms, cube challenges, and you can do English writing. So we can type in, how do you spell something? So, and then the kids have to spell that word out by driving over those letters, and they can do quite a lot of stuff in the game builder. So you can really create custom games, and then they can play them, and that's about going into the lobby and getting the kids to join. I mean, if you guys would like to, if there's time, you can join me in a game. Just copy this link, and this is how easy it is. I'll put it in the chat. If you're on an iPad, it won't work, but if you're on a computer, a Mac or PC or Chromebook, it will work. It will take a little while to load the game the first time because it is a full 3D game.
Okay, yeah. So that's if anybody wants.
And with the student management, I can see as my players join in as well as a teacher. Another great thing with Conundrum is when you are solving a game, we record the time it takes you to solve that game. And then we can also see what coding score you get.
Hey, Bruce.
So, yeah.
I'm so sorry to interrupt, but it looks like we're ready to switch back to the main room because we only have a couple minutes left.
Okay.
Is that okay?
Yeah, that's fine. Yep.
Okay.
Sorry about that, guys. But if you want to join me later after the session, you're most welcome to. I'll just keep this open and you can have a play.
Perfect. All right, I'm going to go ahead and move everybody back to one space. So just a second.
For the pricing is to talk to IdeaCon because they are a reseller, so they'll be able to send you some pricing out. So yeah, just email either Ashley or Heather or Whitney, and they'll be able to send you some prices out as well.
Awesome. It looks like we're all back together.
Right. So thank you very much. I hope it wasn't too crazy. But like we said, we can do a one-on-one demo with you as well. You can just contact them. We'll send some resources, over some information, the brochures, and then also our email addresses that you can then contact us. But Bruce, are you there somewhere?
I am indeed, yeah.
Okay, so have you got a question? I will leave it to the boss to ask the question, and then I don't know how you're going to choose. You're going to have to be very quick on your chat. I think that's the only way we're going to do it. So what I'm going to do, we're going to say the third person that answers the question correctly, that's going to be the winner.
Actually,
so
I'll let Jody pick the question.
Pick the question?
Yeah, pick the question.
Sure. So you want me to ask a question about a general question about Conundrum?
Or anything.
Okay.
Yeah.
Okay. So what do you think is the best age to introduce Conundrum and KaiBots? Who would you what students would you introduce to it if you had a KaiBot today?
Okay. Right, so we have to, what do we say, third person? Okay, so, before, that's going fast. Thank you very, very much. So, Julie was number 1.
Jody on, what was it? The third person, was it?
So, Julie was number 1, Lana was 7, Bob, 3rd grade. So, is that answer correct? 3rd grade, yep.
Oh, are you asking me?
Yeah.
I intend to start with kindergarten. In fact, I did introduce it in kindergarten with my my single KaiBot, and I intend to go up through 8th grade. So for me, it's definitely kindergarten.
Okay.
How'd you get them to read the back of the cards, though?
So they don't have to do that. That's something you can build on. But I think it's really important, like Bruce was saying at the very beginning, what I love about those cards is, and I incorporated just the tiles on my floor in my classroom, talking about, the very introduction to building code, right? If I wanted to pick up this toy that's 3 tiles in front of me, how many times do I have to move forward? So just the physical touching the cards and connecting that with controlling a robot and starting, the language of coding at a really basic age is I think really important. And then all the nonfiction text and the dual language supports, you can start to build and you can scaffold at every grade for me. And I think that's really powerful.
Okay, so then if we look at those answers that you say kindergarten, did you mention that during your talk?
I don't think I did. Somebody said possibly K, though.
Okay, so then we're going to just go with the third person. Right, the third person, I think I said, was Bob. Right, where's Bob? Bob, you won a $50 Amazon card. Thank you very much. Ashley, will you get the details from Bob, and then just let me know, and then just an address, and we can sort that out. So thank you very, very much, everyone. It was amazing, and I hope your brain hasn't gone and yeah, thank you. Bruce?
Yeah, no, thanks, everyone. Sorry, on the second session, I had some bugs and hiccups to show you, but what I was going to show you, what the people in the first session saw, was the ability of the KaiBot to send the code through to Python and Blockly and auto-generate it for you, so kids can really scale from the cards to the Blockly to the Python and, all the way through. So apology about that in the second session, but otherwise things work well.
I think we're all going to do, when we do the vacuuming this weekend in the house, we're going to wish we had a little KaiBot that can be like his mini Roomba and reverse back into his charging dock. So enjoy the rest of your afternoon. And yeah, any questions, please feel free to see, and stay safe. And yeah, I would say safe and warm, but you're warm already. So thank you very much.
Thank you guys so much.